Hello, my online learners. In this video, we're going to continue on looking at biological molecules, and we'll look at the energy that make biological molecules work and how enzymes will help lower that energy. So what I'm working from is the Metabolism and Enzyme Notebook, and I'm also going to be referring to chapter 3.8 of your anatomy textbook. So when we look at chemical reactions are a process which changes a chemical substance into new chemical substances. Now, when we're talking about reactions, there's some vocabulary here. So let's look at the term reactants and products. So reactants are the starting substances, and products is what you get in the end. And what you're really doing is changing chemical bonds. So let's go back to our document. So when we define reactants is the starting substances, and sometimes we use the word substrate instead of substances. And then the products are what we get after the reaction. So let's look at a reaction that is in the body, which is cellular respiration. And in cellular respiration, you're taking glucose, you're reacting it with oxygen to produce carbon dioxide and water. Now, glucose, the formula is C6H12O6. We're adding oxygen, which is O2, getting carbon dioxide and water. The starting reactants are glucose and oxygen. And then the products will be the carbon dioxide and the water. So that's what a product and a reactant is, which we will use these terms quite often in chemistry. Then there's one thing, it's called balancing the reaction, and that's important especially when we look at how the energy is formed. Notice that there are 6 carbons here at the start in the glucose molecule, but there's only 1 in the carbon dioxide molecule. So as a result, you need to add a 6 in order to get what's called balancing the chemicals. Then we next have hydrogen. We have 2 on this side and 12 on this side. So we put a 6 here, and now we have 12 hydrogen on each side. And then the trick is the oxygen, because we've got 6, and then we've got 6 there, we've got 12 there, and then we end up putting a 6 there. Okay, so that is the way we look at a basic terminology for an equation. Good. Next, we're going to look at the energy inside the body. And this is a chemical reaction termed metabolism. Now, the definition of metabolism is overall reactions. And then there is a term called catabolism and anabolism. So let's pop to the textbook to have a look at what these terms are. When we look at biochemical reactions, these are the reactions that are happening in the body. Now, the interesting thing about the human body is the temperature. These reactions have to happen at a certain and regulated temperature. When we look at the overall, the sum of the biological reactions, this is called metabolism. Metabolism can include energy releasing and energy absorbing. So when we look at break down the types of reactions, metabolic reactions can be breaking down, and they are catabolism. And the way I remember that is like a little cat tractor coming and busting things apart. So catabolism reactions break down molecules, and anabolic reactions will build from smaller things into larger. And as they build, they absorb energy. So let's pop back to our document. Okay, so when we define our terms, metabolism is all chemical reactions. So when people say I have a slow metabolism, that's an incorrect use of the term, because metabolism is all energy. Catabolism is breaking down, usually releasing energy, and anabolism is building, usually absorbing energy. And in the process in the body, often we break something down to release energy to something else. Good. When we look at the energy in molecules, we are talking about the activation energy to get things going. So here is a graph we start here with the reactants at a certain energy level, and then the products will have a certain chemical energy level at the end. Often you need to go over this hill of energy in order to get the products at the end. This energy to get things started is called the activation energy. And when we are looking at it in the human body, this energy is usually done by, or is changed using an enzyme. And an enzyme is a protein, usually a protein, that is specially configured to cause a reaction to occur with less energy. So it lowers the activation energy. So if we look at this graph, here we have the blue line is the enzyme added to the reaction. So we start with the same thing, we end with the same thing, but we have less of a hill of energy to go over because the enzyme helps bring these molecules together so they react better or faster. So an enzyme is a chemical that will help a chemical reaction occur by, how does it affect it? It lowers the activation energy. It doesn't speed it up. It doesn't change what you get at the beginning or the end. It just makes it more easy to happen. And enzymes is a way to turn on and shut off a process if you need it to be done. And a perfect example of that is in the stomach. When you have food in the stomach, you release the enzymes to start the breaking down of the food. If there is no food in the stomach, there's no enzymes released because you do not want things to happen if there's no food that's there. Okay? So that is the activation energy. It lowers it. Now, when we're talking energy in the body, we've talked about the process of cellular respiration. Cellular respiration is when you take glucose and oxygen and you react it together using enzymes, and this produces carbon dioxide, which you breathe out, water, which goes into the body and you breathe it out or you pee it out usually, and then adenosine triphosphate. And this is the adenosine triphosphate. We've seen it before. It is a nucleic acid. Here's our sugar, our nitrogen base, and our 3 phosphates. So this is a nucleic acid, and this is an energy molecule used in the body. It takes a lot of energy to put on these last phosphates. So as a result, this molecule will travel around the body, and when energy is needed, it will catabolize or break down, releasing energy to another reaction. And that is how the body undergoes metabolism. Okay? Good. Take a second, finish off your document.